wanted to start out first, kind of, well, doing a quick introduction of, who we are, Humanity, and me and my co-founder, but then get into some of the progress that we've had with the platform so far, and then end with talking a bit about how we see decentralized science and how we look forward to collaborating with some of the people that you'll see speak right after me. So Humanity was built basically as an application to slow down your aging. Our mission, and this is the way that we actually kind of like for a lot of people in the kind of the ecosystem to think about it is, and that they already do, is that our mission is to add healthy years to people. And so everything that we can do, whether it be building Humanity and having that app, or all the great interventions, I just saw my friend Chris talk about Novos, supplement, all the different things that people are working on, just really keeping our finger on the pulse of what the mission really is for all of us, I think, is to add healthy years to people's lives. And our mission, to put it concretely, is to add 1 billion healthy years by the end of the decade. So me and Pete, my co-founder, he always wanted to be an entrepreneur, so he succeeded in his dreams. I wanted to be an astronaut, so maybe I'll buy a ticket one day. But we both got into consumer tech. He created one of the first social networks, had 1 million users before Facebook, had a good exit with that. And I went to Moscow, actually, because I was obsessed with the space program, ended up meeting a guy, and we created what became the largest dating site in the world called Badoo, as you do when you go to Moscow. And really got into tech that way. But although we had that success and then other greater successes as we went, worked on a app that had 900 million users around the world protecting the internet, we got hit by what unfortunately has brought a lot of us into this space, and most of us have encountered in our lives, unfortunately, is people close to us having tragic health events. On my side, I had a relative get late stage cancer diagnosis and pass away. And Pete, his dad, had a stroke out of the blue, killed his quality of life, was in a wheelchair for about 4 years and then passed away. And so at the height of our success, and then we understood that really we had no power to help these two people. And we didn't want to be helpless anymore. We understood that other people were completely helpless in the same situation. And so we set about really going down a lot of rabbit holes, trying to figure out how we could be useful to really help people not have disease. One of the kind of influential charts that I saw through those years was basically this one that we all, I won't preach to the choir and dig into this slide, but we all are here because of it, right? Is as we get older, our bodies become more and more susceptible to disease. And if you go after one disease, you'll just get killed by the other one, 2 or 3 years later. And so we need to go after this base cause, this aging. And one of the instrumental things that happened during that time is first, I met up with people like George Church, because I was looking at early detection of cancer, so genetic sequencing, that sort of stuff. And then when I moved out to the Valley, met up, really serendipitously met up with a lot of folks, including Keith and Oliver at that time when they came and visited, but met up with people like Kristen Fortney, who's doing amazing stuff at BioAge, met up with Joe, who was running his health salons, Brian Kennedy, Eric Verdon, Judy Campisi, just amazing folks, Aubrey with Sens. And so through that time, kind of started to understand that maybe there was something that me and Pete could do. I think I was sitting at the Buck at one point at one of our kind of after a poster presentation kind of meetings, and just understood that someone needed to go out there and do what me and Pete do, is get millions of people to actually start testing their age and start seeing what interventions, even the ones that we have available today, we're doing specifically to those people. And so that's what we created with Humanity. We created an app that is using predominantly in the beginning digital markers, so your movement pattern and your heart rate pattern, and working with great partners like Geer to do that. And so we're getting you a biological age and a rate of aging. You're using that as your real concrete feedback loop. Then you're looking at the whole thing as guidance. So think of it as a navigation app, just like Waze looks at the paths of people ahead of you and then feeds that data back to you to make better decisions. That's what we're doing with Humanity. And then we what Pete and I do well, we gamified it. So all you're trying to do as a user is get your score up every day. And so that's all you have to worry about. And so a couple of the cool things on progress, just really quick charts. We see what everybody that's in this space would expect us to see, that people are the one on the left is showing that across our 130,000 users, their rate of aging is different. So we're all aging at different rates, right? And so that's what we all know, but it's to start seeing that at scale is really important. And then your biological age acceleration is spread across different people and cohorts. And so that's another thing that we know is out there, but to start to see it on 130,000 users is very important, and millions of users soon, right? On the guidance side, what we're also seeing in our data, and this is early days, but 130,000 people is still starting to give us some signal on stuff, is different types of people with different attributes, these different cohorts, and these will get smaller and smaller over time, different actions. And we're talking about lifestyle actions. So we're talking about movement, we're talking about sleep, we're talking about nutrition, we're talking about mindfulness, everything that we do as a lifestyle action, those things are actually affecting us differently. And so we don't really have the luxury of trying to find the cure-all. And I think most of us already kind of know this, we actually need to find what works for a particular type of person at a particular time. And we need some way to continually update them on what they should be doing. I think one of the cool things, and George Church is on our advisory board, I think this was one of the coolest things he thought that he saw during our presentation, was really what we've built is, and something that we want to collaborate with a ton of people, a lot of people attending the conference and speaking at the conference, is we've built a way to have this kind of massive, randomized trial system in the preventative space, because you're talking about interventions that will interact with a lot of other interventions in strong and weak ways. And we need to be able to test them at scale and on large user bases. And that's what we've built. And so our guidance system can actually do that. So you think about it, you're going to have, one of many cohorts will get the guidance to do this, take some extra steps. You can throw another one, the guidance to do, a slightly different rate of, a length of daily fast. And so you can see across that stuff that you'll be able to start to actually differentiate. And this is including things like causal inference and other methods, but this is a way to actually start to interrogate within smaller cohorts what might actually be more effective. So I think just to touch on really the kind of the behavior change and is this thing actually working? I think this is a positive message for us all, is our hypothesis, me and Pete's hypothesis when we created Humanity was, hey, if we just give people a tighter feedback loop on how they're doing, and we do that in the way of biological age, that they will actually start changing their behavior and start heading towards a lower biological age. And what we've seen is that it's true. People are out there with no real concrete feedback loop, and when you give it to them, and a quick one, so using digital markers is definitely a big part of that, but you can use, we definitely see, blood markers and DNA methylation as being part of our offering in the future, and working with partners for that. But when you give them that quick feedback loop, you actually see behavior change. And so this chart is basically, so we can see actually the historic data. The yellow line is when users join Humanity. If you look to the left, that's the 40 days before they join. The reason why we're able to see that is you can see historic movement data in Apple Health. And two things you can see from this chart, hopefully quite clearly, is one, on day one, there's a stark difference in their movement. And very importantly, for actual health change, that's sustained. And so that's something that we've proven at scale now. This is a median number, 15.4%. In some cohorts, and actually the less active ones, you see a greater change, which you kind of would expect to see, but it's also proving that people that are probably less into their fitness and health actually can be motivated by this too. And so the thing that we show in our all hands every Friday is back to that very basic mission: add extra years of health, right? Add healthy years. And so we've already, and this is using Geer's models to verify this, we've already added 30,000 years to our user base. And so for the active users, that's about a half a year. That's a half a year each. And so we're already seeing that this is working. And now it's an idea of scaling and bringing in all the great interventions that everybody is doing to allow for that. So I wanted to take just a few minutes at the end talking about decentralized science, because as we spent a lot of time with different different scientists, I can name a few, like hanging out with Steve Horvath, hanging out with George, hanging out with Kristen, you end up as a scientist spending years of your life collecting data and getting access, either creating the data sets yourself or getting access to the data so that you can do your groundbreaking research. And so one of the most impactful things that we can do as a group, because as a group we have power, is we can actually get easier and easier access to data that we can then train models on, that we can then make discoveries from and bring that to people, right? And so the three tenets of that in my mind are, one, we need to keep the user data private. And for us, it's about keeping the ownership of the data with the user as well, meaning we don't anonymize and send it off somewhere. We actually keep it with the people that the user gives the data to. The purpose is to allow for open access model training, meaning that really anybody with a laptop anywhere, not just a researcher that's connected with a great institution, but really with a laptop anywhere can start to actually train models. This is what happens with text, predictive text, is people anywhere can get a text set and start doing, machine learning on it. And the last one is, we need more data on more people. And so each of us, so humanity, name your other large, Strava, anybody that's collecting large data sets on people, hospital groups, we're always going to have a finite number. And that number is always going to be larger if we can actually train it across not just our data set, but others. And so that's real increase in impact. And so the two things that we're doing, and this is kind of like a call to action. And I'm really excited to see the folks speaking after me, because I know they have some pretty advanced ideas on this and projects as well, is to keep that data privacy, but to, allow for the kind of more open access training so that we don't have to keep these things in very secure places, is actually create synthetic data from the real user data. And so you're trying to keep all the relationships, and that's where you run your deep learning and you get all the distributions and relationships between those variables. You come up with a synthetic data set, so these fake users, but that hold a lot of the same relationships between variables as much as possible. And then we open that up to all the other organizations who are doing the same thing, creating a synthetic data set from the real data, and we allow for the federated learning across that. And it might sound newish and pie in the sky, but actually all this technology exists already. So we're not waiting for any breakthroughs. It's just simply, coming up with, this is a standardization of our data set. This is the best method to create the synthetic data. And then, this is the federated learning system. So a call out to everybody that wants to do the same thing, and people that are great at creating synthetic data, and people that are great at federated learning. So we'd love to speak with you.
All right, Michael, thank you very much. Yeah, we do have, we ended a bit early, so we have plenty of time for questions. So this is a pretty powerful tool that could be used, I guess, for a lot of applications. Not just others, but we're actually, Keith and I are working on some applications as well. Are you partnering with anybody as far as any companies, any groups that are working on anti-aging interventions to be using your platform?
Mm-hmm. So on the intervention side, we haven't partnered yet, but we've had lots of talks. And I think actually most of that has been the reason is that we've been building out, and now we actually have a decent user base, and we have an operational system. So I think actually now is the time to really start having more concrete conversations in that space. But we've been having conversations with folks for a couple of years as we've been building this out, but actually now it'd be cool to start actually doing it for real.
Right. So how would you guess how would you envision that? I mean, one, you could obviously have people use the platform and roll it out to participants, but would there be any room for potential collaboration where they could somehow, I guess, integrate a particular intervention? Like, let's say somebody had some sort of a platform that was also web-based, or or an electronic platform that would somehow mesh with the humanity platform for data collection.
Yeah, so on the data collection side as well, I think what we've created is quite agnostic, right? So and this goes across it can go across the data collection and the intervention. And so just to give you an example, it's not so much in the longevity space, but so if you're doing meditation, what we're mostly doing is, if you're using Calm, I say Calm because there are investors, but there's obviously other meditation apps out there.
Mm-hmm.
If you're using Calm, we're getting that data through on the back end. And so you're still getting your meditation minutes, and we're seeing how that's affecting your biological age. I think most of what we've spoken about doing with others is similar to that. I think if it's a supplement or something like that in the space, then it's quite easy for us to just add that as something that someone could say, hey, I'm taking this thing. And then we're able to monitor it. And I think getting into details a little bit, but doing kind of joint distribution where they push out to all their users, hey, now start monitoring this with humanity. And then us building it in to the app so that people also, know that it's an option. And then the last piece of that is just making it easier for people to, say, buy a supplement or something. Well, I guess the only thing that we're avoiding doing is we really want this to be the data brings the best thing for the best person to the top. But from the just finding out who's taking what and then allowing people to monitor better that are already taking something, we're actively, looking to do that with folks. So.
Gotcha. So I have a question coming in here from somebody. Could you elaborate on how you create synthetic data from your individual user data?
Mm-hmm. Yeah, so I mean, a bit of it is an open question. We're working with, we've just started to investigate this. I have a good friend that was on the protein folding team with DeepMind. And so she and I have been really surveying what the best methods are out there. Unsurprisingly, she thinks some deep learning methods will be the best, and probably they are. And so basically what you want to do first is you run the deep learning on the real user data, and what you're just trying to figure out is which kind of autoencoders, which methods, to keep it a little bit higher level, which methods are going to best pull out all the relationships. Because what you're about to do, that second step, and we do this to make it interoperable with other people training their models, you're about to create a bunch of fake users, but you want those users to contain as much as possible the very multivariance relationships that exist within that data set, right? And so you don't want a lot of loss of data, as in you don't want kind of univariant relationships between all those different biomarkers. You want the multivariance, because that's where the power of the learning can be. And so that's what we're looking at right now. I think it's quite possible, and it's quite easy. It's more we're just in the process of figuring out which is the best one. And then what we want to do is actually then just say to everybody out there, hey, this is the method, go do it. And now we can connect up. The second part of that, though, is the federated learning. And on the federated learning side, actually, I haven't spent as much time finding a good platform to do that. So I think if there's folks out there that have good ideas on that, would be great.
And I think we've got one more question here. How are you currently defining a healthy year?
Yeah, so it's basically, well, first you have you're basically just taking that from the definition of the biological age. And so the biological age is based on our definition of that is that you basically have the probability of disease, and it's a weighted set of disease in these models. You have a probability of disease of the average person within the reference data set that age. And so when you basically add when you get rid of a year, which what you're trying to do, you're trying to get younger, you're basically just saying, hey, you were at 41, you should be at 41, your chronological age is 41, but now you're actually, 40. And so each of those years, so each time you move down the average probability of disease of the person that age, each time you move down a year, we're adding a year to your life. Hopefully that was clear. I could probably say that 5 different ways, but
Awesome. Okay. Well, yeah, I think you've answered everybody's question. Oh, I think we did. Keith, you have a question here. Did we answer that question about the synthetic? Did you want a further elaboration, Keith?
Yeah, I can jump on. Just a quick question. It might help answer the previous question too, Michael. If you can maybe speak a bit about how the synthetic data creation process can be modified or different depending on the scenario. For example, if as a researcher I cared about for disease voice frequency, but I didn't care about voice linguistics, versus what if I cared about linguistics but not frequency? How might that change how the synthetic data is created in those cases? I think that might help. Yeah,
it's a great question. So on the one side, we're looking to make things as agnostic as possible. So I think there's probably 2 processes that end up happening here. One, we try to come up with the autoencoder process that gets us the most containment of all the relationships, multivariate relationships between everything in that data set. Obviously, there's going to be, as you're kind of pointing out with the question, there might be different scenarios where if you had known the scenario up front, you would do the creation of the synthetic data slightly different to optimize for that. I think the great thing that we will have though is for people that are using the system, it can also be quite open, and the metadata can be quite clear who has, say, the most of a certain type of data. And then there can be easily a reach out to those people directly and say, hey, this is my exact use case. And then there can be a collaboration between those two groups. What we want to do with the first part is make it as applicable as possible without the need of these kind of bilateral conversations. But I think the bilateral conversations will still be possible. And case in point, what you're saying, I think would be an example of one place where it might end up being optimal to have that bilateral conversation. So your synthetic data ends up being even more applicable for your use case.
Okay, and maybe you answered this and it flew over my head, but I had another question just come in related to what you just said. What would prevent or limit the model from recreating as synthetic data, the actual data, thus maintaining the most interrelationships?
Yeah, so that might be a bit above my pay grade, but there are proofs that you can do once you create the synthetic data. There are proofs that you can do basically different ways of doing differential privacy, which is a whole space. You're basically saying you're running proofs on that data set to say, hey, is there any single record data within this data set that we've created? And so that those are operations and functions that need to be done, but there are proofs that are quite accepted across the industry for proving that there is none of that. There's no way to go back the other direction.
And one last question, speaking about being agnostic with the data, any plans for the Humanity app to release on Android?
Yes, that's always, but unfortunately, I'm still answering that question. That probably means that we're not moving fast enough to get it out there. Yeah, so we have the good news is we have an Android developer. He's awesome. We hope to hire another one within the next few months. I won't give a date because I'll probably have to eat my words, but let's say that we definitely have a strong push to get it, at least a beta version out by the very end of the year. So.
All right, awesome. Well, no doubt the Android users will be welcoming that.
Yeah,
all right.
I got my pixels, so I feel the pain.